So this lesson now pertains to negative exponents. As you can see on the screen, um, we are not allowed to have negative exponents in order for an expression to be considered simplified. This goes along with Notes 7.1b and Homework 7.1b. So we can see the rule on the screen. It is any number a raised to a negative exponent, like negative m, is the same as the reciprocal, 1 over a to the m. But notice that the negative m exponent turns positive when that power moves to the denominator. So for example, if I write this using numbers, it would look like this. I could say that 2 to the negative cube or third power is the same as 1 over 2 to the positive third or cubed power, which of course is 1 over 8, because 2 cubed is 2 times 2 times 2, which is 8. So let's look at why this is the case. So I have written here that 10 cubed equals 1,000, and I just picked 10 because it's an easy number to see this pattern. 10 cubed is 10 times 10 times 10, which is 1,000. 10 squared is 10 times 10, which is 100. 10 to the 1 power, if we just follow this pattern, we're just taking the decimal point and moving it one place to the left every time we reduce the exponent. So this would be 10. That would make 10 to the 0 power, as we saw in the previous lesson. Move that decimal point one more time, and it becomes 1. So then what happens when we get to 10 to the negative 1 power? Well, we take our decimal point and move it one more time, and this equals 0.1. Well, 0.1 is the same as 1/10. So therefore, I can say that 10 to the negative 1 power is the same as 1 over 10 to the positive 1 power. I can continue the pattern by putting 10 to the negative 2 equals, and again I'll move this decimal point one more place, and I get 0.01. Well, 0.01 is the same as 1/100th. 1 over 100 is the same as 1 over 10 squared. So I see my pattern. 10 to the negative 2 is the same as 1 over 10 to the positive 2. This is just making the point that even though we started out with this rule on the previous screen, what if my negative power starts in the denominator? Well, the rule works the same way. Whatever we have in the denominator with the negative exponent, it moves to the numerator, and the exponent turns positive. So for the one on the right, this is really over 1. So we just flip the fraction and then turn the exponent positive. So no matter where the negative exponent is, it changes position and turns positive. So for example, if I had, let's say, 1 over 2 to the negative 4th power, then this would become 2 to the positive 4th power over 1, which is 16, because 2 to the 4th power is 16. What if both the numerator and the denominator have negative exponents? In that case, both powers change position. So notice right here, the a to the negative m power switches to the denominator, the b to the negative n power switches to the numerator, and for both exponents, the signs change. We could also write that like this, because a over b in parentheses quantity raised to the negative m is the same thing as a to the negative m over b to the negative m. And again, both of these will switch position and become b to the positive m over a to the positive m. And this fraction can be rewritten as seen here. Let's look at the examples on your notes. There are different ways you can do this. You do not always have to follow the same steps or the same order. So on this first one, I'm going to follow what's in this text box here. Multiply the coefficients first. That will give me 16 because I have 2 times 8. Then I'll use the product rule for the exponents and I'll add them. So that will give me x, and then if I notice, the two exponents are -4 and +2. So if I add those together, I end up with -2 for my exponent, because -4 plus 2 is -2. Moving on to this step, the x is going to move to the denominator because it has a negative exponent. After I move it, the exponent changes signs. So this will give me 16 over x squared. And that's your answer. For example 2, sometimes you'll end up with questions with coefficients. So if we want to divide the coefficients. In this case, we can. 6 divided by 2 is 3. But you can't always divide them evenly. Sometimes you can reduce them though. So at least try to reduce them. Otherwise, you just leave it as is. Next thing we'll do is just rewrite the p to the -2 over p to the -4. Second step here. Both of my variables have negative exponents. So remember, when that's the case, I'm going to switch their positions and change the signs of the exponents. So that means this is going to give me 3, and then the p to the -4 is now going to be in the numerator with a positive exponent. The p to the -2 is now in the denominator, and it too now has a positive exponent. Now I can use my quotient rule from the previous lesson, and I get 3p squared because I just subtract the exponents for the quotient rule. Example 3. Notice that the negative exponent has parentheses in front of it. That means the -7 exponent applies to everything in the parentheses. So we'll follow this step here. So we'll rewrite this as a fraction, 1 over 2b to the 7th power. Next, the exponent applies to both the 2 and the b. So my final answer here will be 1 over 2 to the 7th power. Well, 2 to the 7th power is 128. So I get 128 and then b to the 7th. And that's my answer. And the last example on the notes. For example 4, there's a curveball here with, because we have a minus sign in front and a lot of negative exponents. So let's just take it a step at a time. The coefficients do not reduce, so they are going to remain all the way through to the answer. So I can already write negative and then put a fraction bar, and we'll put 5/4. Every variable that has a negative exponent is going to switch. So the negative exponent in the numerator is going to switch to the denominator. And I will end up with x to the positive 6 in the denominator. This y cubed will remain in the numerator. Then both of the negative exponents in the denominator will move to the numerator. So that means I'm going to extend my fraction bar here. The x to the negative 5 is going to end up in the numerator as x to the positive 5. The y to the negative 3 will move to the numerator as y to the positive 3. Now finally, my answer. I know I'm going to have a negative and a fraction and 5/4. My numerator has an x to the 5th, that came from there. But then I'm going to take my y cubed and y cubed, and I'm going to combine those into y to the 6th. Because remember, when we're multiplying expressions with, that are powers, we add the exponents if the bases are the same. My numerator is still x to the 6th. I have one last step. Shorten that fraction bar a little. My last step, I still have my negative 5/4. And notice that I now have an x to the 5th in the numerator and an x to the 6th in the denominator. The x to the 5th is going to cancel with 5 of these x's in the denominator. Since 5 of them are canceling and there were 6, that leaves me with 1 x in the denominator. This y to the 6th will stay where it is. And this is your answer. Notice I have no negative exponents, so it is simplified. Let's take a look at a couple of the even numbers from the assignment. So on number 4, I'm going to multiply the coefficients. 7 times 6 gives me 42. And then I have a k to the negative 1 times k to the negative 7. I can add those exponents, and that gives me k to the negative 8. Since I have a negative exponent, and I'm not allowed to, I will rewrite this as 42 over k to the positive 8. And we have one more. Number 12. They threw in a negative sign in the denominator just to confuse you. but it's not that big of a deal. We're just going to write this as, I'm going to just put the negative sign in front of the whole fraction. There is a coefficient of 3 in the numerator, and there's nothing to divide that by. There's nothing to simplify it with, so it stays. The x to the 7th in the numerator will stay. The y to the negative 6th in the numerator is going to move to the denominator, and it will become y to the positive 6. Be careful here, because this x to the 8th with the negative sign in front, that is not a negative exponent, so it does not move. It stays in the denominator. So we still have an x to the 8th and a y to the 4th in the denominator. Oh, that's ugly. Let me fix that. We'll put x to the 8th, y to the 4th. Last step to simplify this. My negative sign stays. My 3 stays. Notice that I have 7 x's in the numerator. I have 8 x's in the denominator. That means that all 7 x's in the numerator are going to cancel, with 7 of the 8 in the denominator, leaving me with x to the 1. My denominator also has a y. Since it's y to the 6th times y to the 4th, I add those exponents to get y to the 10th. And I do not need my fraction bar quite that long. So my final answer is this. And that'll do it for this lesson. If you have any questions, text me on Remind, or email me at ctodd@amphi.com. Thank you.